All right, it's time to move from quadrant 1 to the rest of the coordinate plane. We're going to look at angles in each of the 4 quadrants and have a look at whether their trigonometric functions are positive or negative. I'm going to draw the same triangle in each quadrant, but there's nothing magic about the angle that I've chosen. All quadrant 1 angles will behave the same way. All quadrant 2 angles, 3 and 4, will behave as we'll detail here. These are just examples to help us develop a general understanding of the signs of trigonometric functions in each quadrant. I'm going to start with an angle whose terminal side runs through the point 7, 4. It's of course in standard position, so it begins on the positive x-axis. Since it's in quadrant 1, I'll keep it easy and label this one as theta 1. We can use this point 7, 4 to draw a right angle triangle. So we can see that the x value will be 7, the value of y will be 4, and we have to find the value of r. We can do that using the Pythagorean theorem. R will be the square root of 7 squared plus 4 squared. In other words, the square root of 49 plus 16, or the square root of 65. We'll leave it as the exact answer and not move to decimals. All right, let's have a look at the trig functions for this angle. The sine of theta 1, y over r, is 4 over the square root of 65. The cosine of theta 1, x over r, is 7 over the square root of 65. And finally, the tangent, y over x, for this angle is 4 over 7. Nothing unusual here. We notice that the sine, the cosine, and the tangent are all positive, as we expect. This always happens in quadrant 1 because we're looking at trig functions inside of right angle triangles. Let's look at quadrant 2. I'm going to draw an angle with a terminal side passing through the point -7, 4. It's in standard position, so it's an angle greater than 90 but less than 180 degrees, and I'll label it as theta 2, as it is in quadrant 2. Again, we can use that point -7, 4 to create a right angle triangle, and we see that the value of x is -7, the value of y is +4, and of course the value of r will still be 65. The value of r will always be positive. Let's look at the trig functions here. The sine of theta 2 is 4 over the square root of 65. So far, exactly the same as the quadrant 1 angle. The cosine of quadrant 2 is the first one where we notice a difference. In this case, it's -7 over positive root 65. So that ratio, the entire ratio, is negative. As is the tangent. The tangent here is going, of the angle, will be 4 over -7. Or we could write that as -4 over 7. Let's look at the same triangle in quadrant 3. For this angle, the terminal side goes through the point -7, -4. There's nothing special about the x-y coordinates I've chosen. All quadrant 3 angles will behave in generally the same way. All quadrant 3 angles will have negative x values as well as negative y values. So this one has an x value of -7, a y value of -4, and an r value of square root 65. Let's write out those trig functions again. So the sine of theta 3, in this case, is negative for the first time because the value of y is negative. The cosine, same thing. The value of x is negative, so the trig function is also negative. But the tangent turns out to be positive because -4 over -7 is the same as +4 over +7. And finally, we'll draw an angle where the terminal side runs through the point 7, -4. So this gives us a quadrant 4 angle. I'll call that one theta 4. Here's our right angle triangle, has an x value of 7, a y value of -4, and of course an r value of 65. So the sine of theta 4 is going to be negative with -4 over root 65. Whereas the cosine is once again positive because we've got a positive value for x over a positive value for r. Of course, r is always positive. And finally, the tangent of that angle, -4 over +7, is also negative. Let's look a little more closely at what's going on. In quadrant 1, sine, cosine, and tangent are all positive ratios. So let's highlight the positive ratios in each quadrant. So we can say these are all positive. In quadrant 2, it was only the sine of the angle that had a positive value. So here it's only sine that we find as positive. The cosine and the tangent of that angle are both negative values. In quadrant 3, tangent is the only one that's positive. So we have tangent positive for all quadrant 3 angles. And finally, it was cosine in quadrant 4. That was positive. So cosine for all quadrant 4 angles will be positive. We look at the first letter in each word, and we call this the cast rule. So in quadrant 1, all angles will have positive trig ratios. In quadrant 2, it's only sine. In quadrant 3, it's only tangent. And in quadrant 4, only cosine. We can summarize this by writing C, A, S, T in the 4 quadrants. Think of this as well. If sine is positive in quadrant 1 and quadrant 2, we have to remember that sine will be negative in quadrant 3 and quadrant 4, and so on. Let's apply this. In this question, we're being asked whether the ratios, so the sine of 140 degrees, for example, of these trigonometric functions, will be positive or negative. Let's sketch out the cast rule, just so we remember what each piece is. This is always a good idea to do. Well, 140 degrees is an angle in quadrant 2, greater than 90, less than 180 degrees. In quadrant 2, sine will always be positive. So the sine of 140 degrees, whatever ratio that might be, will be a positive value. What about the tangent of 185 degrees? Well, 185 degrees is in quadrant 3. Again, tangent turns out to be positive in quadrant 3. So the tangent of 185 degrees will be a positive value. Try this on your calculator. And lastly, the sine of 200 degrees. Well, what quadrant is 200 degrees in? It's in quadrant 3. But it's only tangent that's positive in quadrant 3. So the sine of 200 degrees is a negative value. Let's look at it from the other side. If we know whether the ratio is positive or negative, we can determine which quadrant the terminal side of that angle must reside in. In the first question, we're told that the tangent of this angle is a negative value. Okay. Again, I'm going to draw my cast rule. If I know that the value is negative, well, then the angle can't be in quadrant 1 or in quadrant 3. Tangent would be positive in those quadrants. So the solution must be in quadrant 2 or in quadrant 4. What about the cosine of theta being equal to 0.866? Well, that's a positive ratio. Cosine is positive if you've got an angle in quadrant 4 or in quadrant 1. This last one looks a little bit trickier. We're told that the cosecant of an angle is equal to negative 2.866. Well, cosecant of theta is really just the reciprocal of sine theta. It would be 1 over sine theta. And taking the reciprocal of a value doesn't change it from positive to negative and vice versa. So if the cosecant of an angle is negative, the sine of that angle will be negative as well. So we can simply think of this as, where is the sine of this angle going to be negative? Well, the sine of the angle will be positive in quadrant 1 and quadrant 2, so it will be negative in quadrant 3 and in quadrant 4. Notice that when we have one piece of information, as we do in this question, we will always have two solutions. And finally, in this example, we're looking at two pieces of information, so that will help us narrow down the answer to a single quadrant. Start with my cast rule. In this case, we're not told explicit ratios, but we are told whether that ratio is a positive or a negative value. Here we're told that the cosine of the angle is greater than 0, so it's positive. So where is it positive? Well, that's in quadrant 1 or quadrant 4. Quadrant 1 or quadrant 4. But now we have a second piece of information that helps us narrow down the answer. We're told that the sine of the angle is a value less than 0 or negative. Well, sine is positive in quadrant 1 and quadrant 2, and negative in quadrant 3 and quadrant 4. So the only place they have overlap is in quadrant 4. This angle, given the restrictions, is in quadrant 4. Here's another one where we're using a reciprocal trig function. We're given the cotangent. If you like, you can think of this as the tangent of the angle is greater than 0. Because it's not giving us the specific ratio anyway, it's irrelevant whether we think of this as cotangent or tangent. So we're looking for a quadrant where a tangent is positive. So that's either quadrant 1 or quadrant 3. But the cosine must be negative. Cosine is positive in 4 and in 1. So it's negative in 2 and in 3. Quadrant 3 satisfies both conditions. And then finally, in this last example, we're told that the tangent is greater than 0. So we're in quadrant 1 or in quadrant 3. But that the sine is less than 0. So we must be, once again, in quadrant 3.